Algebra 1 Common Core, June 2016 Regents exam. This is the 5th video in the series that's going to cover the entire Regents exam, and we're picking up on number 20. The dot plot shown below represents the number of pets owned by students in a class. So what this, the way dot plots work out, this means that there were basically 2 students that had 0 pets, 2 students that had 1 pet. There were 5 students that had 2 pets, and 5 students that had 3 pets, and so on. Which statement about the data is not true? I remember, always circle things like not or false or all that stuff. So which is not true? The median is 3. The interquartile range is 2. The mean is 3. So remember, we always want to test all these choices for true, false questions like this, not just, think one is the answer and move on. And the way to really best get this is from the data in our calculator by doing one variable statistics. So I think I'm going to type all this stuff into my calculator. And remember, this just represents 2 zeros, 2 ones. There's going to be, 5 twos, 5 threes. And so let's input this data. So it'll be much easier to pull out things like mean, median, and range and stuff like that. So we have a stat button in our calculator, and if we hit enter right away in edit, it brings us to our lists. L1, L2, L3 stands for list 1, list 2, list 3. And we want to enter that data in. And so I'm sorry I can't have them both up on the same screen. At least I haven't figured that out yet. But basically we want to type in what we have here. We have 0 twice because there were 2 dots above 0. There were 2 dots above 1. 5 dots above 2. So I'm going to put 2 in a total of 5 times. So it was 3, 4, 5. And there were also 5 threes. So 1, 2, 3, 4, 5. And 3 fours. 1, 2, 3. 2 fives. 1, 2. And 1, 6. And, the thing that most students, when they make a mistake on a stat question, is they put the data in wrong. So I always like to kind of double check it. 6, 2 fives. 3 fours, 1, 2, 3, 4, 5 threes, 1. Just make sure I don't have a 6 3 in there. Nope. Okay. There's 1, 2, 3, 4, 5. Right. And then 1, 2, 3, 4, 5 twos. 1, 2, 1, 2. Okay, so I have them all in there. So stat. Then we go over to calc for one variable statistics. And your list is L1 because that's where we put the data. There's no frequency list there. I guess we could have done it as a frequency table if we wanted to. Just wrote 0, 1, 2, 0 through 6 and then said how many zeros, how many ones, how many twos. So that would work, but go with what we have here. All right, so we see the mean is 2.75. Standard deviation is 1.577. The minimum is 20. The max is 6. So from the minimum is 0. Sorry, there's 20 numbers. From 0 to 6 is your range. So your range is 6. Your interquartile range is from Q1 to Q3, so 2 to 4. So there's a difference of 2 there. The median is 3. All right, so now let's look at some of these choices. The median is 3. That is true. The interquartile range is 2. That is also true. The mean is 3. I believe the mean was a decimal, so I think that's going to be our false. And if we look that back up here, 2.75. It rounds to 3, but it's not exactly 3. So I think that's false, but let me check out my last choice. The data contain no outliers. An outlier is when there's like 1 or 2 pieces of data that don't really fit with everything. Like if there was one student in the class that had like 15 pets, that would throw off, the mean and stuff like that. That's not the case here. Everybody is, 6 is by itself, but it's, I wouldn't consider it an outlier. An outlier is, when there's kind of a gap and then there's a number way far away from everything. So that is also true. So the mean is not 3. The mean is 2.75. Number 21, what is the largest integer x for which the value of f of x will be greater than the value of g of x? And they give us these equations. Again, this is another calculator question. So in our y equals utility, we want to type in these 2 functions. The function f of x, 5x to the 4th power plus 30x squared plus 9 and g of x is just 3 raised to the x. All right, and let's see what this thing looks like. May have to move my window around a little bit if I don't see anything, but I should see some stuff. There's 3 to the x, but it looks like I'm having trouble seeing the 5x to the 4th plus 30x. I see a little boop, something right there. So I could, let me try adjusting my window. Let me change my y max. I want to see further up. Let me change that to 50 and see if I could see a little more of what's going on here. Oh, there it is. Yep. So the 10 was a little too short, and there's 3 to the x right there. All right, and so then the question is, for which value of x will f of x be greater than g of x? And if you compare their tables, so for what value of x, now f of x is in our y1, and g of x is in our y2. For which value of x, what is the largest integer of x? So let me pull up the question again so you don't have to memorize. What is the largest integer x for which the value of this is greater than the value of this? So, when is y1 greater than y2? And so you look at these, you see y1 is much bigger than y2. But we want to say, how long is that true for? See, here we see 9 is greater than 1. 44 is greater than 3. 209 is greater than 9, so on, so on. But eventually, we should start to see maybe that gap close a little bit. All right, so we're at 35,000, 19,000, 53,000, 50. This is the first time where the y2 column, which is our g of x column, is greater than our y1 column. And again, if we go back to the graph, if we could see these things, we'd have to zoom out quite a bit. But we'd see that eventually this curve is above this parabola-looking graph here. So that is the first time that this graph gets higher up than this one does. So that's at an x value of 10. Heavy calculator question. I mean, I guess if you wanted to do it without a calculator, you could substitute these values in for x and actually get the results. But again, your results are, we're talking about things in the, in the 50,000 range, so they're dealing with pretty large numbers. It's a pure calculator question. All right, number 22, another calculator question. The graphs of this and this, what statement is true about them? So again, let me type in the f of x and g of x into my y1 and y2. And you're probably seeing a trend here that there are a fair amount of questions on this Regents exam that require you to use your calculator. Not necessarily require. Sometimes there are ways to do it without the calculator, but the calculator really is a huge tool for this algebra exam. I want to get rid of that little piece there too. All right, so the absolute value of x minus 3 plus 1 and 2x plus 1. You get that absolute value by doing math to the right. All right, let me go zoom 6 to get back to a normal looking view. All right, so we have our picture here. We see they're crossing in this spot, and they want to know which of the following is true. So when f of x equals g of x, f of x equals g of x, so this is talking about when they cross or the graphs intersect when. So all of this stuff really wants to know, when do the graphs cross? So I'm going to use the calculate utility. So second trace brings you to the calculate folder, and I want to know where they intersect, choice 5. And move my Toodles friend over to the point of intersection and hit enter 3 times. 1, 2, 3. And the answer is 1, 3. So they intersect at 1, 3. So they intersect when x equals 3? No, it's when y equals 3. They intersect when y equals 1? No, it's when x equals 1. So what are they referring to? The solution to f of x equals g of x. The solution of f of x equals g of x is referring to the x values. And that I think is a little confusing the way that that's worded. So I believe the answer here is choice B. The solution to f of x equals g of x. It's basically saying for what x value are they going to have the same y value. And I get why that's a little confusing. So that's kind of a trap question right there, I believe. All right, let's see if we can get maybe one or two more in here. The store sells self-serve frozen yogurt sundaes. The function represents the cost in dollars of a sundae, weighing W ounces. An appropriate domain for the function would be what? So the two dimensions of this are basically the weight versus the cost, right? So your weight here, how much the frozen yogurt weighs depends on how much it's going to cost. And so a domain is referring to your x values. So this would be our weight here. All right, C of W, like W is replacing x and domain is x. So what's an appropriate domain for the weight of frozen yogurt? Could you use integers? Well, the problem with integers is integers are positive and negative, and you don't really have a negative weight of something. So that doesn't really make sense. Rational numbers. Well, rational numbers can also be negative, and that's kind of what we were talking about. Now, these say non-negative, so that makes more sense. Non-negative integers or non-negative rationals. What makes more sense? Well, again, integers are just, positive and negative. Well, in this case, we're doing non-negative integers, so we talk about 0, 1, 2, 3, 4. The reason why the answer is D is because, yes, you can have frozen yogurt that weighs 1 ounce, 2 ounce, 3 ounce, 4 ounces, but you could have something that weighs 2.7 ounces. And integers do not have any decimals in between these whole numbers. And we need to have a cost system that, what if somebody wants to buy 2.5 ounces of frozen yogurt? And rational numbers are all of the numbers between these. And again, the non-negative is what takes care of the whole negative issue. All right, number 24, the last part 1 question, last multiple choice. Sarah was asked to solve this word problem. The product of 2 consecutive integers is 56. Product. Remember, product means multiplication. Now, consecutive integers, the way that always works out is you let the x equal the first integer, and then if it's just consecutive, x plus 1 equals the second integer. Consecutive integers are like 5, 6, 7, 8, just in a row. Now, if it were to say consecutive even or consecutive odd, then we would have x still be the first, but then x plus 2 would be the one after it, because even and odd integers, like every even integer is 2 apart, right? 2, 4, 6, 2 away from each other. And the same thing for odd integers. 5, 7, 9, 2 away from each other. So your second integer would have to be x plus 2. But not the case here. The product. So if I multiply these together, it equals 156. So that's x times x plus 1 equals 156. And if you work this out a little bit, you get x squared plus x equals 156. And what type of equation are we creating? That's what this problem is asking. No, sorry about that. I lost the pen feature for a second. Is this a linear function? Well, linear functions have degree 1, meaning the highest exponent is 1. Here our highest exponent is 2, so that's not it. Quadratic equations are degree 2, highest exponent of 2. Yes, that's what's happening here. Exponential equations are when x is the exponent. Not the case. Absolute value has the absolute value bars. Again, not the case. So this is a quadratic equation which you could set equal to 0 and then solve. All right, that's it. That finishes the part 1s. Our next video will pick up on number 25, the first part 2. See ya.